Hello all. In the previous video we have completed the periodic property PYQs. In this video we will be dealing with atomic structure. Again I will be making two videos, part 1 and part 2. In part 1, in this video I'll be covering all the PYQs of KCET of the chapter atomic structure from the year 2008 to 2014. So let's begin. And one more thing that I have noticed, most of the question in from this timeline, most of the questions were from principal quantum number. Were from quantum number, calculation of quantum number. Like there are 4 quantum numbers. We will be learning that further. So let's see in the year what were the questions that were asked in the year 2008. So the first question is, when the azimuthal quantum number has the value 2, the number of orbital is possible. Before that, let's see what is quantum number. Quantum number, there are 4 quantum numbers: N, L, M and S. S is called spin quantum number. M is called magnetic quantum number. L is azimuthal or angular, muthal or also called as angular, and N is the period or principal quantum number. These are the 4 quantum numbers that can define or is an address of an electron: N, L, M and S. N is called principal quantum number, L is called azimuthal quantum number, M is called magnetic and S is called spin. After that, let's see here, when the azimuthal quantum number has value 2, so L is equal to 2. There is one more trick. Number of L is nothing but it defines the shape of the orbitals, and L shape of the orbitals. Those orbitals are, or I can say, a shape of a subshell. So subshells are S, P, D, F. These are the 4 subshells. Let's see the value of these subshells or value of L. That is 0, 1, 2 and 3. 0, 1, 2 and 3. After that, 0, 1, 2 and 3. Now each S orbital, we know that S orbital has one, S subshell has 1 orbital. P subshell has 3 orbitals. D subshell has 5 orbitals: 1, 2, 3, 4 and 5. Whereas S subshell has 7 orbitals: 1, 2, 3, 4, 5, 6 and 7. These are number of orbitals. So we have S subshell has 1 orbital, P subshell has 3 orbital, D subshell has 5 orbital and F subshell has 7 orbital. Each orbital can accommodate 2 electrons. So S orbital has how many electrons? 2. P subshell can accommodate maximum of 6 electrons. D can accommodate, say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So D can accommodate 10 electrons. Similarly, F subshell can accommodate 14 electrons. So this is a general introduction to solve, or a more basic trick is present in this setup. That is, L is the azimuthal quantum number. The quantum number are 4, and principal quantum number L is azimuthal, M is magnetic, S is spin. Now they have, particularly based on this question, I have solved here. S are of 4 types: This S defines the shape of the subshell. We have S, P, D, and F. The values of S are 0, 1, 2, 3. A number of orbitals for S is 1, then P is 3, D is 5, and F is 7. Now let's go back to the question. An azimuthal quantum number is L is equal to 2. So L is equal to, value of L is equal to 2 is here. So answer is D. D subshell they are talking about. The number of orbital possible in that. Okay, they have asked the value of L is 2. And what is the orbital? Number of orbitals. So number of orbital is how much? 1, 2, 3, 4, 5. So number of orbital is 5. Answer is 2. Hope that is clear. Next, let's see 2009 paper. The correct set of 4 quantum number. Again, 4 quantum number. What are those? N, L, M, and S. Spin are of only 2 types. That is plus half or minus half. And this is in the order itself. This N 4 matlab N. Here next is L. Next is M. And the last one is S. This is in the same order. You have to write the quantum number in this order itself. N, L, M, and S. They have asked outermost electronic configuration of potassium. So what is the quantum number? What is the address of the outermost electron of potassium? Before that, to know any of the electronic configuration, the best easiest way is, first you need to know all the noble gas configuration. Helium, we have next neon, argon, krypton, xenon, and radon. They have atomic number 2, 10 here, argon 18, krypton 36, xenon 54, and radon 86. Okay, you have to know. Then after this, the corresponding set that you have to write is, for helium you will write 2s, neon 3s, argon 4s, krypton 5s, xenon 6s, and radon 7s. Let's imagine I want to write oxygen electronic configuration. Rather than writing 1s2, 2s2, 3s2, 3p4, I can skip this part. And I can write helium 2, because atomic number of oxygen is 18. 18 is closer, 18 comes after helium 2. So helium 2, we have already, next number you have to write is 2s2. So helium 2 plus 2 is 4. Next after 2s2 we get 3s2. So we have 2 plus 2 4. 4 plus 2 is 6. We need to have 8 atomic number, 8 electrons. So extra 2 we need. And next is, wait one second, 2 plus 2 4. 4 plus 2, okay, here I have made a mistake. Oxygen electronic configuration is 8. 8 we have 1s2, 2s2, 2p4. They have by mistake I have written 3s2. That is wrong. This is the exact configuration. So we can skip this part. Now I have to, with the help of these Nobel's configuration, how can I write an electronic configuration? So that is in this way. You just see where 8 comes. Before 8 the value is 2. You can't write 10 because it exceeds 8. So you can write this helium 2 configuration. You can write helium 2. The next you have to write is 2s. Maximum it can fill 2 electron. So total, if you see, we have helium 2 plus 2, 4 electrons are done. We need 4 more to complete 8 electrons. So after 2s2 we have 2p4. In this way also you can write electronic configuration. Both the ways possible. But when you move down the group, that if you see calcium, magnesium, to write electronic configuration with the help of 1s2, 2s2, 3s2, long process, it is very time consuming and it is difficult. So most of them tend to go with this order. This is important. Now let's see, they have asked potassium. Potassium, they have given atomic number as 19. So it has 19 electron. So let's see first let's like electronic configuration of potassium K. It comes after argon 18. Argon 18 and 4s2. We need 19 and it is not 4s2, it is 4s1. 18 plus 1 is 19. This is outermost electronic configuration. N is nothing but, hope this much is clear. Now let's see how to identify the quantum number. First we'll write atomic principal quantum number. N is nothing but period, or this is principal quantum number. Here 4s1, this is nothing but ns1, so n is equal to 4. We have 1 and 3 option, it has n is equal to 4. Next, both for all it can be plus half or minus half. S is same, but then you have to see what is the value of L and M. L, again I said, it gives about subshell. And what were those values of L? We had 4 subshells S, P, D, F. S value was 0, P had 1, D had 2 and F had 3. So now here we have NS. S value is 0. So L is 0. L0 value is here. So first is the right option. But let's see what is magnetic momentum. Magnetic momentum, it talks about the magnetic property or magnetic moment, magnetic quantum number. Now here the value goes from plus L to minus L value. Now let's take example. If L is 3, then the M value will be plus 3, plus 2, plus 1, 0, minus 2, okay, wait, I have made a mistake. It is, the M value is minus L to plus L. Sorry, I have made a mistake, student. So M value is minus L to plus L. Let's take an example. If L is equal to 3 value, so M value is minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. So here in this question, L is, we have L value is 0, L value is 0, N value is 4. So M value automatically it will be 0. So M is also 0. So correct option is first one. Hope this is crystal clear. What is the principal quantum number, azimuthal quantum number, spin quantum number and magnetic quantum number. So magnetic quantum, principal quantum number talks about the period, the L talks about the subshell, and the M talks about the orientation of orbital, how the orbitals are oriented, and S talks about the spin of the electron. This is 2009 question. Let's see one more question in 2009. It is about de Broglie's wavelength. The question is the body of mass x. Whenever such question is given, you just write the given, then you will be easily able to solve the question. So the body of mass m of x kg. So mass is given, mass is equal to x kg, is moving with the velocity. Velocity is also given 100 meter per second. Its de Broglie wavelength is given 6.626 in 10 to the power minus 35 meter. Planck's constant also given. They are asking the mass. We have learned the de Broglie wavelength equation, lambda is equal to h mv. We want mass here, so we can rewrite this formula as m is equal to h divided by lambda v. Put all the givens. Planck constant 6.626 into minus 34 here. Whenever in atomic structure or whenever any physical chemistry related any question, make sure along with writing, first one, make sure along with writing the formula and putting adding all the given values, make sure to write even the SI unit, because it is important to deduct and to make sure that whatever value we get, whatever SI unit you have at the end, is it the same as an SI unit, or you are supposed to convert it to some other units. So make sure to write units also for each and every values. So the here 6 point, the Planck's constant unit is joule second. Now lambda is given, that is 6.626 into 10 to the power minus 35 meter, and velocity is given 100 meter per second inverse. Okay. Now this 6.2 cancels out, that will be 0.1 into here 10 to the power minus 35 goes up, it becomes 10 to the power plus 1. Is it? Huh. Okay, wait 1 second. This will be 1 into 10 to the power minus it is minus 35 moves up, it will be plus 35, minus 35 will be plus 1. After that it will be joule second meter square second inverse. Okay. And if you move 10 plus 10, if I move the decimal this side, it will be, I'll write it here, it will be 0.1. We have joule second, this second inverse, wait, meter per second here, meter per second, meter per second. This meter per second, this second square, if it goes up meter per second, the meter per second goes up from the denominator to the numerator, it will be joule second square meter square. One thing, this 0.1 value we got, so directly we can calculate as 0.1, but sometimes there might be some different but the values are similar but the unit is not same. How to get this unit? That is, this is one note point. 1 joule is equal to kg meter square second square. 1 joule is equal to kg meter square per second square. This you have to note down. 1 joule is equal to kg meter square second square. So put this 1 joule into the given value, that is 0.1 into joule is kg meter square per second square, and we also have here second square per meter square, it gets cancelled out, so then we'll get 0.1 kg. So the correct answer for this option is third one. Next 2010 question, again it is about the wave number of the spectral line of the emission spectrum of hydrogen will be equal to 8 by 9 times of the Rydberg constant if the electron jumps around. Now the question is wave number is inversely proportional to wavelength, that is lambda. There is a formula for this wavelength or wave number, that is R Rydberg constant z square in the bracket 1 by n1 square minus 1 by n2 square over 1 by n1 square minus 1 by n2 square. Now let's put all the what the question is. The wave number is equal to Rydberg constant R is given. We need 8 by 9 is equal to R. This is the answer. Okay, they're asking how did this 8 by 9 come and what were those n and n1 and n2 value to get this 8.9 value. So we have to find which value holds 8 by 9 as an answer. Here z square is equal to 1 because we are finding it in hydrogen spectrum. Now let's see, it is option elimination method. So first one is n. Now here n1, which is n1 and n2, all if you see it is emitted, so it was an electron was in higher this is ground state, n1 is equal to 1. Electron, so n is equal to 1, so this is n1. Let's imagine electron is here, it is present in n is equal to 3. It is present in n is equal to 3. This they take it as n2. So electron is jumped back from n is equal to 2 to n is equal to 1. That is how it works. So here n1 is ground state here and n2 is in excited state. So let's see each value. So the electron jumps from n is equal to 10. So n is here, n is equal to 10 to n is equal to 2. Let's put this value 1 by n1 square, that is 10 square, minus 1 by 1 square. 10 square will be 100. Numerator will be 100. Here we need denominator will be 100. We need denominator as 9. So first one is eliminated. Second one we see n is equal to 3, that is, see here, n is equal to 3. Here is the value. N is equal to 3, electron jumps from n is equal to 1. Let's see how it is. Rydberg constant R is equal to wave number is equal to Rydberg constant 1 by, which is n1, n1 is 1 square, minus, which is n2, n2 is 3 square, R is equal to 1 by 1 minus 1 by 3 square is 9, and you will get 8 by 9 as the value. So correct option is 2, where electron jumps from n is equal to 3 to n is equal to 1. Next question of 2010 paper, that is about the quantum number of the outermost electron of copper. Okay, this is a very good question because copper has electronic configuration Cu denoted as 3d10 4s1. Many students make a mistake writing it as 3d9 4s2, which is complete wrong. It is 3d10 4s1. Now in this 3d, people tend to think now which is before that, which is the outermost electron. Let's see. And outermost electron, always the outermost electron where n value is highest. This is the nucleus. We have 1, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. We all know this. N has only here s orbital, s subshell is present. We have s subshell and we have p subshell here. In n is equal to 3, we have s subshell, p subshell and d subshell. So we call it as 3s, 3p and 3d. Here we have 2s and 2p only. We don't have 2d. Here we have again 4s, 4p, 4d and 4f also. So this 4s1, this n is equal to 4 will be outermost shell, and the electronic configuration in that shell is for copper is 4s1. Let's see the quantum number, or let's see this electron's quantum number, that is this electron's address. What is n? We'll find out what is L, what is M and what is S. Pause the video, try to solve by your way. If you find the answer, well and good. If not, see the solution what it is. So 4s1, that is nothing but n is 1. So n is equal to 4, and always quantum number sequences n, L, M and S. Last one is spin. So all spins are same. It will be plus or minus half, no difference. You have to see n, L and M. Now n is equal to 4. Where is n is equal to 4? Other than option 1, rest all have n is equal to 4. Let's see L. Again, L values range from 0, 1, 2 and 3. For S it is 0, for P it is 1, for D it is 2 and for 3 it is F. Okay. So it is S, so S value is 0. Where is L value as 0? Okay, the correct option is fourth one. Hope this is clear, my student. Okay, this they have asked outermost electron. Next, let's see 2011 option. If the energies if the energies of two photons is in the ratio of wavelength. What is the wavelength? Okay, energy is given and wavelength is given. So the formula will be E is equal to h nu is the formula. Nu can be written as C by lambda. So nu energy the energy will be energy and wavelength can be hc is equal to lambda. Okay, now we know V1 by V2 is given 3 by 2. They're asking what is ratio of y1 by y2. Now directly you can see here energy and wavelength are inversely proportional. So there whatever energy value will be, that will be reciprocal of that of wavelength. So if the energy value of E1 and E2 is 3 by 2, so lambda 1 by lambda 2 will be 2 by 3. Obviously it is a common sense, but if this thing doesn't strike, then let's go by formula way. Our correct option is second one. So formula wise if you go, we have E1 by E2. Write the E1 formula hc by lambda 1 divided by hc by lambda 2. The common term cancel out. This lambda 2 comes up. E1 to the numerator E2 divided by lambda 2 by lambda 1. E1 value is 3 by 2 is equal to lambda 2 by lambda 1. They want ratio of lambda 1 divided by lambda 2. It will be 2 by 3. In this way also you can go, this way also you can go according to your choice. Next one we have is again quantum number. So from this way you can understand how quantum number, how much it is important. More you learn about quantum number, easier it is. Now the highest energy level in an atom. Okay, this is something new. Whenever they ask something like highest energy level, lowest energy level, when the quantum number is given, what you're supposed to do? You have to just see n plus nl value. If n plus l value is low or is small, then if n plus l is small value, then energy is less energy. If at all it is a bigger value, then the energy will be more. Let's see n plus l value for all the options. Here 4 plus 0 is 4, 3 plus 2 is 5, 3 plus 1 is 4, 3 plus 0 is 3. So the highest n plus value is 5. So option they have here highest. So option is 3. If the question would be lowest, then the option would be fourth one. Hope this is clear. Moving on to 2012 paper, again see again about the 4 quantum number. Which are the 4 quantum number? Principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Spin can be plus of, minus of, everything it is same. For sodium they have asked. Sodium, what is the formula? You can go with helium, you can go with neon. Neon has 10 and it has 3 is 1. So 10 plus 1 is 11, atomic number 11. This way, or you can go long way, 1 is 2, 2 is 2, 2 is 6, 3 is 1, in that way you can go. So this is nothing but n is equal to 1, so n is equal to 3, all are 3, s is equal to 0, so s0 is in this option. Hope this is. M you have to find. How? What's the value of m? M value ranges from minus L to plus L. Here L is only 0, so M is also 0. Fourth one is an option. 2013 electronic configuration of Cu2 plus. It is theoretical. You are supposed to know. Ground state of Cu is 3d10, 4s1. They have asked Cu2 plus. So the configuration is one electron goes from 4s1 and the next electron goes from 3d10. It will be 3d9. 4 is 0. Correct option is second one. 2014 question, one of the most interesting question, and the question that I liked, the statement that is not correct. Okay, let's see which is not correct. First definition: energies of the stationary state in the hydrogen like atom is inversely proportional to the square of the principal quantum number. Yeah, that is right, because there is a formula to find out energy of a stationary state in hydrogen, that is delta E is equal to 2.18 10 to the power minus 18 joule, n initial square to n final square. If you see, energy is inversely proportional to principal quantum number, that is n. First option is right. There is no problem in the first option. The radius of the first orbit of He plus is half of the first orbit of hydrogen. For radius of an atom is given by 0.529 n square divided by z. Now let's first find out for radius of hydrogen. 0.529 n square. Hydrogen has electronic configuration 1s1, so n is 1. Z is also atomic number of hydrogen is 1, so radius of hydrogen is 0.529 angstrom. Here next they have asked radius of He plus. He plus hydrogen helium electronic configuration is 1s2. As one electron is lost, so the configuration is 1s1. 0.529. So now we are finding radius of helium plus. N square here, n is 1 square. Atomic number of Z is 2 divided by angstrom. So ReH plus is equal to 0.529 divided by half a square. What is a 0.529? Not a square. Angstrom is nothing but radius of hydrogen. Again, this we can write R radius of helium plus is equal to radius of hydrogen by half divided by angstrom. So the second question is radius of first orbit of He plus. He plus is half of that of first orbit of RH hydrogen. This is also right. Angular momentum. Okay, this is you're supposed to learn, that is to find out. Okay, angular quantum number signifies the shape of the orbital, right? Angular quantum number is nothing but azimuthal quantum number. Azimuthal quantum denoted as L. It talks about S, P, D, F. It talks about the shape of the orbitals. How S is spherical, how P is in an how D is in a double shaped, how P is in dumbbell shaped. All those shapes is spoken up by azimuthal quantum number, also called as angular quantum number. Next, this is total. All these three option is wrong, so the correct option will, the statement that is wrong is fourth one. But we need to know how to solve this. This is one more again a formula based total number of node. The nodes are of two types. We have nodes are of two types: radial node and angular node. Radial node and angular node. I shall erase all this. Hope you have written radial node and angular node. Total, if you add both, gives the total number of nodes. Radial node is given by formula n minus L minus 1. Angular node given by formulas n. So if you count here, the question is 3s is given. The value of n is 3 and value of L is 0. So if you equate n is 3 minus 0 minus 1, so here it is 2 value, and L is equal to, here it is 0. So if we add n radial node plus angular node plus 0, total node will be 2 and not 3. So this fourth statement is wrong statement. Last PYQs we will see, that is 2015 paper. The next 2016-17 paper till 2025 will be in part 2 section. So let's see the question. The two electrons, this is quite similar to that of previously which we have done. That is this one. This paper, that is 2011 paper, and 2015 paper is quite similar. That is, the two electrons are having following set of quantum number. Which statement is true? They are talking about the energies. So as I said, whenever quantum number is given, how to find out the energy? Just by looking at n plus L value. If the value is small, then the energy is less. If this value is big, then the energy is more. Now if you see P has quantum number 3, 2, N, L, M and S. So if we add 3 plus 2, here it will be 5, that is N plus L. Here also Q, oh, this is N, L, M and S. If you again add N plus L, it will be 3. So we have P has greater energy than Q. Let's see the statement. Which statement is true? They have asked. P and Q have same energy. This is wrong. P has greater energy than Q. This is the right option. So in this video, we have covered the questions, the PYQs of the chapter Atomic Structure from 2008 to 2015. Hope you have liked. If you have any queries, any doubt in any question, comment down in the comment section. I will reply as soon as possible. Hope you all liked this